Hello, everyone. Thank you for joining us today. We have a great panel and showcase of AI and energy startup companies for you, and we're thankful that you decided to join us today for this event. I wanted to thank Tony Sun, who's the chair of the GCV Global Energy Council, as well as Rita Waite from InQtel, who is the co-chair of the AI Council for GCV, as well as others on those councils who have helped put forth some of these startups for you to view today after our panel discussion. So I'm going to turn this actually over to Tony Sun so that he can introduce his panelists and we can get started with the program.
Yeah, thank you very much, Janice. And hello, everyone. This is Tony Sun calling from GC Ventures. So we are the CVC arm of a Thailand-based energy and chemical company. And currently, like Janice mentioned, I serve as the chair for the Global Corporate Venturing Energy Council and working closely with peers to support the GCV team on their energy-related initiatives, just like this one, which is also a collaboration with the AI Council. And today, we are very fortunate to be able to invite two visionaries from the industry joining me, exploring the opportunities and challenges at the intersection between AI and energy. And for the next 35 minutes, so I will throw some questions to our renowned panelists, and if time permits, we'll also try to answer a few questions from the Q&A box, which the audience can find from below. So, all right, so without further ado, maybe I would like to invite our panelists do a quick intro of themselves. So maybe, Sid, do you mind kicking off the session by saying a few words about yourself?
Sure. Thank you very much, Tony, for having me for the panel and of course for your generous introduction. So I'm Siddharth Singh. Feel free to call me Sid. I work in the office of the Chief Energy Economist here at the International Energy Agency. I'm based in Paris, and I also lead the work stream on energy and AI at the IEA.
Yeah, thank you, Sid. And Lisbeth, want to go next?
Sure. Yeah. Thanks so much. So Lizbeth Kaufman here. I'm head of climate tech startups at Amazon Web Services, AWS. So my team and I are here to work with climate tech startups and make sure that AWS is being as helpful as possible. And I have a background, I'm a founder myself. So I ran a venture-backed startup before joining AWS. And I also have a background in climate policy before that. So very glad to be here.
Awesome, thank you, Lisbeth. And as the audience can tell, we kind of like very thoughtfully try to pick the expert who we think sit right at the intersection between those two really hot topics. So with that, maybe I'll probably go after you, Sid. So data center energy consumption is probably one of the hottest topics nowadays, and your report from IEA confirms that with high growth numbers, right? And so I'm curious, from your perspective, how can the energy sector adapt to meet this demand sustainably?
Thanks, Tony. That's a very good question. So maybe I can start by taking a step back and understanding how the energy demand actually is expected to grow moving into the future. So as we started our analysis, to understand how this new vector of data centers is going to impact the energy system, we started by mapping out all of the ones that are in existence at a large commercial scale globally. So there are over 11,000 data centers spread across the world. Most of them are based in the United States, in the European Union, and in China. But of course, there are emerging clusters also in Southeast Asia, in Africa, in Latin America, and India, and other places. So we did a mapping of all these data centers, and we found some pretty interesting and fascinating things. So firstly, we saw that these data centers tend to cluster around cities. So it's not just a case of as it would be for, say, steel mills or aluminum smelters, which are pretty dispersed out. Data centers, on the other hand, tend to accumulate around each other, and they tend to be close to urban areas. So this creates a new dimension of energy demand because of the nature of its concentration. The other thing we saw is that they're getting larger very quickly. So as an example, today, a hyperscaler data center that's catered to AI could consume as much electricity as 100,000 households. But the largest one under construction today, which will be online in the next year or so, could consume as much electricity as 2 million households. So the data centers are getting larger in size, and they're coming up very quickly. So while the energy infrastructure can take 5 to 10 years even to get constructed, data centers can come up in 2 to 3 years, which is much less time, and therefore there's a mismatch between the expectations of the technology sector on the one side and the energy sector on the other. So as a result of this rise, we find that the total electricity consumption from data centers is expected to more than double by 2030. So by 2030, the total electricity consumption by data centers could be as much as the whole country of Japan consumes today, or would consume in 2030. So all data centers equals to a Japan, which is one of the largest economies globally. The challenge that we have is how can we meet this rising demand sustainably? We find from our analysis that up to 50% of the growth in supply for data centers can come from renewables, but the rest of the other half will have to come from a wide variety of sources, including gas, coal, natural, nuclear, and so on, because of the nature of demand. It is because of the nature of the demand profile from data centers, which tends to be relatively flat. So you have electricity consumption happening through the course of the day, for which you need more dispatchable source of electricity. Ultimately, the challenge lies with the energy sector as to how can we create that infrastructure to have 24/7 matching of renewables, plus, of course, nuclear where it's available, and also battery and other forms of storage to ensure that you have increasing amounts of electricity going in that is clean. And that is the big challenge that I think is there with the energy sector today.
Okay, thanks, Sid. Maybe turn to Lisbeth a little bit, because I think AWS is definitely a big consumer of a massive consumer of the energy over here, and you are leading AWS climate tech startups team. So can you share what you see from your perspective? Like, what are the key strategies AWS is implementing to power its data center and improve its energy efficiency and related topics?
Yeah, absolutely. So yeah, as you noted, I'm on the startups side of the business, working with the startups, not necessarily, working on data center infrastructure. But we do really sit at an interesting intersection here. And AWS and Amazon broadly are, really focused on making the cloud the most energy efficient and sustainable way for our customers to run their infrastructure. So there's a lot going on. Most broadly speaking, we have the climate pledge, which is the goal to get to net zero carbon emissions by 2040. So feeding up into that is a great deal of work on renewable energy. So we already actually power all of our operations with 100% matched renewable energy. And that's been 2 years in a row now. We hit that goal 7 years early. So like, as Sid mentioned, data centers, like AWS data centers, we're certainly using a lot of energy to run our operations and including AI. But if we're going to use energy, we're very focused on making it renewable energy. And then we have a lot of initiatives to make our facilities more energy efficient. So, we have we're actually what's a really interesting space is how our facilities are using AI to improve our energy efficiency. So they have systems to ensure that buildings are working as efficiently as possible and identifying potential faults and failures. And then I should also mention we have we're very focused on making our chips run as efficiently as possible. And that's pretty fundamental for AI's energy use. So we have our inferentium chips and our trainium chips, as well as a chip called Graviton, that are some of the most energy efficient options at AWS. So lots going on focusing on energy efficiency and powering our operations with renewable energy.
Great, great, great. Yeah, hopefully you can also mention a few case studies as we got for the rest of the sessions. So maybe for both of you, because both of you have been monitoring this space for long enough, and what do you think are the main barriers preventing the widespread adoption of AI technology in the energy industry? Because I'm more of an energy/chemical guy, and our sector is often characterized by the long-established infrastructure and practices. So how do you guys see the key? Where's the barrier?
Well, actually, before we get into the barrier, I work with so many startups that are using AI in energy and across the climate space. So from my perspective, I actually get to see so many cool examples of startups leveraging AI to address the climate crisis. So I can share even a few examples of that. And before we then talk about the barriers.
Yeah, please.
So actually I run a fellowship program called the Compute for Climate Fellowship, and it's a grant funding program for climate tech startups to leverage our most advanced cloud computing like AI. So we have a few companies in the fellowship that are really cool examples of this. So we just announced our last cohort, which has 23 companies, and there's a company called Ever, which is closed loop geothermal. And they can do geothermal anywhere in the world. And they are in the fellowship program working with AI, building an AI-powered system that can do real-time optimization of their drilling, which is really important because there's a great deal at stake when they're drilling. The machinery is worth millions and millions of dollars just going down. There's so many things to consider. So they have this system that can work in real time to basically control the drilling and tell it what to do to make sure that it's all going as planned and as effective as possible. So that's one example of energy startup that's using AI to run its operations. I got many more too. Got it.
Great. And maybe Sid, if you can comment a little bit on the barrier side, and then coming.
Sure, of course. And I mean, just to complement the points that were made by Lisbeth. So we also have seen some very interesting case studies of how AI is being adopted by the energy industry towards various types of goals. Increasing, for example, the accuracy of forecasts so that we can integrate more solar into the system, as an example, or finding ways to improve the performance of freight operators. So these are large delivery systems. How do you ensure the best routes are used to minimize energy use and emissions? So there are a range of opportunities in this space. But you're right, Tony. There are several barriers that kind of hinder the uptake at a more widespread level. So if I could perhaps talk through a few of them. The first, I think, broader kind of barrier is that at the policy level, we lack the incentives that would encourage an uptake of AI in the first place. So to give you an example, you need more energy efficiency to eventually get you towards your long-term climate goals. And the kinds of energy efficiency that needs to be unlocked in the building sector, for example, they don't exist right now. At least they don't exist in most jurisdictions around the world. So you need incentives to ensure that operators of commercial buildings have certain forms of digitization and other devices that can eventually have a layer of AI and you can lead to optimization. But that very incentive does not exist. The policy incentive does not exist. So that's, I think, one of the key barriers. But we have been in talks with a lot of energy companies, and they have flagged issues of data availability, for example. So as an example, we spoke to this particular grid operator who said that we would like to time the supply of more renewable energy to when demand peaks, but there's no way for us to really understand what the user profile is for example, for washing machines, or at the individual household level. When is it that electricity demand is going to peak, and how can we better manage the system in a real-time basis. So that kind of real-time operation application of AI is only enabled when you have more seamless data sharing across entities. So that's another, I think, barrier that we're really not able to cross. And one other issue that a lot of companies talked about is the lack of skills. Again, this should not come as a surprise, because the salaries in the technology sector are almost twice as high as an equivalent position in the energy sector for a person who's an expert in AI and software. So naturally, the energy sector has a challenge in attracting the right kind of talent, which as a result creates a barrier in the adoption of AI. But I'm sure there are many more, and I'm sure Lisbeth can maybe talk about one or two other barriers that she may see from her perspective.
Yeah, what you mentioned, Sid, really resonates. And actually, specifically your second point about, I guess, like knowledge. We see that even in startups, who are super innovative and cutting edge, but often the technical teams in like deep tech companies, like fusion companies or whatever, they come from academia and they're experts in their specific field of science and engineering, but they might not be as up to speed on AI. So sometimes they don't necessarily understand, or they're just not aware of like the benefits that AI can offer to help them speed up their development, their building. So in part, I think like that's on us folks, companies like AWS. Like we need to make sure that we're helping everyone understand how AI can be helpful in building these solutions for energy and the climate crisis. And that is why my team is here. Like we're here to help with companies that are eager to build with AI and our cloud services in general.
Cool. Maybe Sid, I'll go after some the first comment you made, right? So my understanding of IEA is kind of intergovernment agency, right? And I'm curious, what specific policy recommendations is IEA making to the government to ensure that the growth of AI is sustainable and does not derail their climate goals? And also, how should public and private investment be prioritized along those lines?
Yeah. That's a very good question, and you're right. One of our key objectives as an agency is to provide the kind of information that's needed by our member governments or by governments more broadly to make good decisions about the future of their energy and their sustainability needs. So in this case, we have a few kind of broad themes where that we have tried to flag to our governments. So for example, one issue that we found that data center operators often flag is that they lack the kind of information needed to make better decisions about the location of data centers. Location of data centers can be a very interesting variable to work with, because if you can site data centers closer to where renewable electricity or other forms of low emissions electricity is generated, you could potentially reduce the load on the grid as a whole. Secondly, you can also locate data centers in a manner that does not burden the grid given other developments in the economy. So after all, data centers is just one part of the equation. There are many other consumers, and they all are coming up independently without much I guess discussion or planning happening between them. So one of the things that we often tell our member governments is how can we provide better information signals so that data center operators have the information they need to make better decisions on where to site the data centers. Secondly, how can they even integrate their backup capacity? So all data centers have backup capacity that's almost equal to the total capacity of the servers and the racks and all of that itself. So how do you ensure that backup capacity can be used perhaps in times when there's high stress on the grids? There are some very interesting examples of how some companies working with technology majors in the United States have been able to manage demand peaks at certain times of the day. So, for example, when there's high stress on the grid, because there's a lot of demand happening at that time. How can you ensure that data centers are better integrated by reducing demand, but they're reducing demand by actually deploying some of the backup capacity? And there are some very interesting experiments happening along those lines. So these are a couple of examples, but of course there are many others. I mean, to maybe give you one final policy recommendation that we often make. This is regarding the interoperability of various parts of the electricity system. So as an example, is your washing machine aware that if it were to turn on at a certain time of the day, it would be able to better use the solar electricity, which may be peaking at certain time of the day? The fact is that there is no way for your washing machine to have that communication with the grid, and in turn the grid with the suppliers, and in turn that with the general understanding of when certain forms of energy will peak in the system. So to have a certain common language for different devices and different parts of the system to talk to each other, you need a broader interoperability kind of protocol, or a language in which they can communicate. And I think that is something that that regulators also must think about as we move towards a future where there are more connected devices, where there is more variable renewable electricity in the system, where there are more batteries, where there are electric vehicles that are connected to the grid. So all of these different parts of the puzzle, if they're able to talk to each other, you'll really be able to optimize the use of AI towards a more efficient and optimized electricity system as a whole.
Perfect. Yeah.
And I think you just made, those are great points. And also just to add to your last point, enabling all of these devices to talk to each other would be a great use case for AI, right? Like AI itself can enable that. And we work with some companies that are building virtual power plants. So we've got a company, Asoba, which is using AI to build the first virtual power plant on the African continent. So I think there's so much opportunity there with managing demand and distributed energy resources and devices like that.
Yeah, thanks, Lisbeth. And then since we're talking about looking into the future, so I'm curious to understand, let's say fast forward 10 years, right? Let's looking at 2035. What do you hope the relationship between AI and energy will look like at the time? And I'd appreciate if both of you can give me, each of you can give me two scenarios. What's the, let's say, the most optimistic scenario, and also what's the most concerning one?
Sure. Should I go first,
So
or
you're gonna go try first?
Okay. Yeah, sure. Happy to jump in. So we actually did some analysis here, to understand what potential futures could look like. And let me start with the first part of the equation, which is energy for AI, which is the energy needed by AI and by data centers. The optimistic scenario would be that data centers are just better integrated into the system. They're able to make better decisions on location. They're able to provide the kind of flexibility that is needed in the system, the same types of flexibility that happens in across various industries. You're able to really participate in the system in a manner that you can tap onto 24/7 renewable electricity and play a constructive role in the electricity system as a whole. So that's one part of the puzzle. The other part is the AI applications in the energy sector, towards optimization and innovation and so on. And we did some pretty interesting analysis. So if I can talk about the aggregate impacts. So we find firstly that AI applications in the industrial sector. So this means automation, it means robotics, it means the use of computer vision towards optimizing various processes in a manufacturing setup. If all those applications were to be scaled up, if we were to overcome all the barriers, if we were to scale up all of these things, we would be able to save energy to the equivalent of 8 exajoules, which is about the total consumption of Mexico. So the whole country of Mexico, the entire system, the energy that it consumes in any given year is the amount of energy that can be saved just by the industrial applications of AI. Similarly, if you look at the transport sector, there are examples of, I mentioned optimization of freight. There are other such examples of where AI is being used in automobiles, in the railway sector, even in aviation. And the total impact across the transportation sector would be the equivalent of removing 120 million cars from the roads. So, that's the potential of AI, even using existing technologies. So this does not factor in new radical technologies that may come out in the next, 5 or 10 years. We're talking about existing technologies, if they are scaled up, can have such a massive impact. So that's the optimistic side. That is, if we are able to overcome the barriers, if we have better information sharing between the tech industry and energy industry and so on. But the flip side is that if we are not able to overcome the barriers, we will see that the gains that we make don't materialize. In fact, the data centers in a scenario where there's radical uptake of AI and data centers on the one hand, and we're not able to provide renewables on the other, we end up seeing data centers being the second largest source of emissions growth from now to 2035. So over the next 10 years, data centers could contribute to the second highest source of emissions growth. But that is if things go wrong. That is if we are unable to meet the growing demand with renewables on the one side, and we're also really not able to overcome the barriers. But I'm not a negative guy. I think, I'm a little optimistic that we will be able to solve many of these problems, even though we may not be able to meet the full potential of AI, because there are some barriers that are just very, very structural. But I'm still optimistic that we'll be able to make some progress between now and 2035.
Yeah, thanks, Steve.
Yeah, I think a lot of what you said resonates. And, I like to think about this AI and energy relationship as a flywheel, because I think they can really feed each other. So on one hand, AI is a powerful tool for the energy industry to speed up its decarbonization efforts. So like we're seeing this now, right, with companies that I'm working with. So I mentioned Evor, the geothermal company. We're also working with a bunch of different fusion companies. So I've been working with Realtive Fusion, Thea Energy, Exemer. We just announced it in our newest cohort of our fellowship. And it's really exciting to see how AI is helping the fusion space speed up their R&D, so that they can ultimately get to commercialization more quickly. So there's this sort of AI helping energy speed up, and then when they get there, these energy solutions can help to decarbonize AI and then also help to power AI. And as that flywheel starts spinning, I think we're going to see it go faster and faster. And there's just a lot of opportunity. That I think presents a lot of exciting opportunities for the future, for a world in 2035 where we've got like abundant clean energy powering our AI needs, which is then, powering innovation across the economy. And then I think, on the flip side, concerning is time. We're sort of in a race against time here. So that's why I think about, AI as how can we use this to speed things up, so that we can address our energy needs as quickly as possible.
Great. I think we are all cautiously optimistic about what the future will look like, and hopefully that's the direction where we're going. I do see that there are a few audience questions coming in, so I probably read through some of those. So the first question I have over here is, what are the best ways to identify the ideal location of a data center from an energy perspective? So I think, Sid, you comment on that a little bit. Maybe you can tap into that a little bit first.
Yeah, sure. So first, I want to just recognize the constraints that we have. The constraints are that ultimately the demand for information for data comes from urban areas, and therefore it is natural for data centers to be located close to the source of demand, just to ensure there's low latency, especially in a time when data centers have multiple objectives. They don't just do AI. They're also there's streaming services, there's gaming, there's a lot of other applications that really require real-time feedback from the computation that you're using. So that's the constraint. But ideally there should be, if you're working with the regulators, there should be information on renewable rich areas. There should be information on which areas don't have constraints on grid capacity. The grids issue is particularly a very big one because in recent years renewable electricity generation has taken off very rapidly, but the construction of grids has not kept pace. So we have many areas where you have way more power generation capacity than the infrastructure that can carry that electricity to the cities and other areas of demand. But if we were to ensure that those data centers were coming up in areas that don't have that kind of grid congestion and that are also renewable rich, some parts of the data center computation can be moved there, especially that relates to AI model training, for example. That does not need to be close to the cities. It can happen at any time of the day. There are other such uses of other such computation demand that does not have latency related constraints. And I feel that a combination of these approaches, where the technology sector works well with the energy sector and the regulators, would lead to better outcomes and better decision making as far as locations go.
Great. Any comments from Lisbeth on that?
We have a lot of smart people at AWS who are thinking through that, and I'm not one of them. I'm not an expert about citing data centers. So I think I'll leave it to Sid, and he gave a great answer.
Great. Yeah, thanks. All right. The next question is, I think this is probably, I'm gonna paraphrase the question a little bit. I think this is probably more about talent/skill sets needed in the future as we talk about the growth of this intersection between AI and energy. And so the question is really, what are maybe some like the new skill sets or talent that you think would be needed from a workforce career development perspective?
I can start. So, within we've had AI for decades now. Within AI, there's a lot of excitement and a lot of activity in the generative AI space. So I think this is an area that is worthwhile for upskilling in. And within climate tech startups, it's been so fast, but over the past 9 months or so, we're really seeing the adoption of generative AI to address energy challenges and climate challenge. I'm really seeing it accelerate. So in particular, there's leveraging tools built with generative AI for operational efficiencies. But then there's also actually building generative AI foundation models to address specific climate challenges. And I'm really seeing a flurry of companies that are building their own foundation models in the climate space. So I think that's a really exciting area. And I can actually give an example of a company we're working with. It's called Anthrogen, and they're building a foundation model that invents new proteins and enzymes that can do things like convert carbon dioxide into negative, zero carbon fuels. So that's just one example, but there are, I think, a lot of applications there. So definitely a fruitful area for study and upskilling.
And I'm going to defer to Lisbeth on this. She clearly has a better line of sight as far as skills go. From our perspective, these are the similar kind of cases that we have come across where companies say that they have technologists, but at the intersection of technology and energy, like the core energy sector, that kind of gap is currently the one that is proving harder to fill. But as Lisbeth said, that there are opportunities, and hopefully there'll be skills that or the right talent to solve those kinds of problems.
Great. All right. Seems like we are right on time. Elizabeth and thank you very much, both again, for sharing your insights and the time. And I trust the audience will be just like me, getting a lot of, takeaways and think deeper on this topic about whatever they are doing over here. And again, thank you very much. And with that, I think we will be kind of closing up on the first part of the event. After this, we'll be having quite a few interesting startups sharing about their innovation, how they position themselves at the intersection between AI and energy, and help solve some of the problems that Sid and Elizabeth alluded earlier. So with that, I'm gonna turn it to Janice. Thank you, Janice.
Thank you, Tony. And thank you so much, Elizabeth and Sid. All three of you just did a great job, and I think people have really appreciated the conversation. If we did not get to your question today, I just wanted to let you know that there'll be an opportunity for some follow-up that we will be doing on this webinar. So don't worry if we didn't get to you, we will try to respond as a follow-up to this event. So now we're going to move into the portfolio showcase. First off, we will have Christine from Ardent do her presentation. So Christine, please.
Thank you. There we go. Okay, it's lovely to see you all today. And to start this presentation off, I want to actually borrow from Jane Austen, who started one of her most famous novels with an inevitable truth, or a truth universally acknowledged. And I think a universal truth that we see in today's world is that people will still require the material building blocks that they expect to live the lives that they live today, and that we will continue to need more power. And at Ardent, we're focused on engineering that inevitability with the universal unlock that is membranes. And when we think about industry and power, this is the largest source of CO2 emissions without a clear path to decarbonization. And we all know that we would like to have the power and materials that we need without impacting the environment and the world that we live in. And this analysis was done even before we understood how much power AI would require, which is that assets that are in the ground today would emit 600 gigatons of CO2 from existing industrial plants if they aren't decommissioned or decarbonized in the near future. We believe that point source carbon capture is one of the most practical options to meet these goals. And when we look at this, carbon emissions come in a variety of different sources and a variety of different sizes, both inside and outside the US. So this isn't something where a silver bullet technology that is widely applicable can solve all our problems at once. But instead, we need to focus on solutions that are easy to turn down, flexible, so they can deal with a range of concentrations and a range of sizes, which means that we should look at a modular technology, something that is low energy, so we don't even more increase the energy demands of our ecosystem today, something that's chemical free so we don't contribute to pollution, and something that is a small footprint and very cost effective. So when we think about this, we think about the analogy of cars, right? Some people may need a sedan, some people may need an SUV, some people may need a semiconductor or semi truck, but everyone will need something that can be produced modularly and cost effectively to really combat these solutions for the world. And as Ardent looks at this, this is about addressing a $1 trillion market and solving one of the world's greatest challenges. And there are small, medium, and long-term applications in which carbon capture can make a real difference to the world that we're living in now. And we focus on what can we do in the near term to earn the right to do large applications down the line, like natural gas power gen that will be required for developments like AI. And so when we look at this, the technology that Ardent has developed and the universal unlock that we're looking at is something that has both high flow, requires low pressure so that we don't require even more power to operate the system, and has a low utility demand. And it needs to be flexible. So as Elizabeth said, we can either store that CO2 underground, or maybe we can feed it to other processes that will use it as a feedstock going forward. So how all of this works is that Ardent relies on patented chemistry that is doing the work for us and pulling the CO2 across a membrane so that we don't require more pressure and therefore more energy for the systems. We're focused on a modular design that is compact and not large and bespoke. So how do we make the car type modules on large manufacturing lines that can be deployed in lots of different places? And we're actually using AI to power our system design and make sure that it is as efficient as possible for plants, and so that we can do control without needing an excessive amount of people monitoring these. So that all drives lower compression, lower operating costs, and lower capital costs for our customers. So as we look at why does this technology work, we've actually put it in the field in 3 different applications thus far, and 2 more that turned on this summer. So steel, cement, petrochemicals, and then the 2 that turned on this summer are in more traditional boiler and power gas, power generation applications. And what we see from that is that the membranes are doing what we said they would, which means that they are performing as expected and matching our lab data in CO2 enrichment, but also that they're easy to use for operators, not something that's very complicated, has good longevity, and able to turn up and turn down as power and industry needs, because plants don't always run at the same condition throughout the year or even throughout the day if they're running campaigns. So with that, I'll close and say thank you. And we would love for you to join us in engineering the inevitable of creating power gen and materials sustainably and equitably for the world that we live in today. Thank you.
Thank you, Christine. Now we're going to move to Jose from Beyond Limits. Thank you, Jose.
Right, I'm going to get up and going here. All right, hopefully everybody can see me. Get this up and going. Can you see this? All right, Jose Lazares, I'm the Chief Product Officer at Beyond Limits. I'm just going to spend a few minutes talking about Beyond Limits today. Beyond Limits started in 2014 as a spinoff of Caltech and NASA JPL technologies that were used in the Mars Land Rover and other kind of missions. And we've always started and always been focused on one single mission. That is basically to bring autonomous operations to the real world. And so using our space technology and our patented hybrid AI approach, where we combine machine learning, generative AI, and what we call cognitive or symbolic reason, we really work with our customers to deliver intelligent, adaptive solutions and systems that reliably work in a complex environments where data is often limited, as was talked about a little bit earlier. Obviously, the rise of agentic, we started as a multi-agent architecture and have evolved ourselves to leverage agentic really to help accelerate the development of those autonomous systems, and really to make it so that you can plan, act, and coordinate tasks more efficiently. Bringing that together is what Beyond AI is all about, and our focal point is really on how do we automate and optimize operations, increase performance through efficiency, and ensure that in these complex situations where failure is high, the cost of failure is high, how do we deliver reliable, sustainable, and efficient operations globally? Today, we're kind of focused on 4 key areas. We're a little bit later stage than maybe the previous startup that you heard. We've been around since 2014, and we focus on 4 key areas: global supply chain optimization, production optimization at the plant level with this asset reliability, safety, security, and inspection through vision-based technologies, and the emerging enterprise LLM and agentic AI. Our core markets are focused on oil and gas, utilities, energy, and manufacturing. But despite all the promise of this 200 billion plus market, we've seen that AI over the years has actually not been as effective as we want. And earlier in the conversation, it was mentioned by many, some of the roadblocks that we see out there. It's estimated that really only 1 in 5 of the actual pilots that are done ever make their way to production. So it's a 20% hit rate, 80% don't actually see the light of day. And what we found over time is many of the topics that were discussed in the panel today were there, right? Like really, how do you have data access and system interoperability in these remote environments where often the data is not available, or it's spread across multiple assets and sensors and information? How do you deliver actual models that are explainable? Because these are high stakes environments, and explainability and enabling people to do that is a major must, and our current numeric models often fall short of that. One key thing that was mentioned is expert knowledge. How do you capture and actually use that knowledge to help automate decision making when much of that knowledge, that tacit knowledge, is within the experts' heads and those that have been in the industry for a long time? In fact, that's one of the core challenges that we see as beyond upskilling and training others. There's this huge resistance that's often driven by the fact of this brain drain and this loss of manpower that's happening over the last 10 and coming years. So it's a really important thing, not to mention cost and your data privacy and data concerns within these, very high risk, high reward environments. So these are some of the challenges that we see. To help address that, we really bring what we call the Beyond AI platform. This is our no-code hybrid agentic solution that helps you perceive, plan, and execute actions to help you automate the core processes in a dynamic fashion. I'm not going to spend a tremendous amount of time here. The point I want to make is that we bring together structured and real-time data and unstructured data through machine learning and large language models. What really differentiates Beyond Limits is that we believe that expert knowledge capture and being able to use that to guardrail or to help make decisions based on the inputs from your experts, really to drive decision making, helps with upskilling, it helps with knowledge capture, it helps with retention of the expertise that you have within your system. So what we do is we take these streams and then we basically apply that using our symbolic cognitive reasoners, our advanced reasoners, to actually discern and make decisions in a much more cost-effective and energy-efficient manner for that case. And we do that providing a studio for subject matter experts to be able to build out AI workflows that they can use to basically deliver that. And we provide a set of ongoing solutions across the spectrum to allow that to happen more efficiently. I'm just going to leave you with one example of recent work that we've been doing with in the oil and gas sector with the super major NOC in the Middle East. Really, the goal here was how do they go about optimizing their operations globally? They had multiple facilities, JV ventures globally across the stand, and they had very little visibility into how to maximize and be efficient across this whole global planning organization. So what we built for them is a standardized approach to basically planning and centralizing that. We basically focused on applying machine learning and anomaly detection to market and prediction responsiveness for production so that they could identify challenges, make adjustments more effectively, and really drive the cost of production and planning much more smoothly. A key goal is to drive that down into the downstream plants to basically support intermonth optimization, because today their planning is in weeks, not in minutes or hours. And so really the goal is how do you really do crew rationalization and make adjustments so that you can be more efficient in the use of energy, in the use of the production to get the most out of what you're doing. And then finally, they wanted this to be driven and generated through an agentic AI engine that allowed them to basically ask questions, be able to gain perspective on challenges that they have, and be able to make decisions more collaboratively in a common place. And to that end, this is just a little video of the output of what was put together. Really, you can see here, this is a command center really that covers all of the facilities, basically allows them to basically go in and look at various components, how the overall system is operating, and then within that context, be able to ask natural language questions using a large language model that's been fine-tuned to their purposes, and basically do it in an agentic fashion where they can actually issue commands, identify challenges, and then move forward from there. So I'm just going to wrap it up. I think from my perspective is what we're really providing is AI that delivers autonomous intelligence at scale. It's self-optimizing, it's multimodal. We focus really on secure private clouds. As we heard earlier, there are public clouds, but at the edge, you often are working behind a firewall in a secure environment. We leverage our NASA heritage and the intelligence that's provided in the form of these advanced symbolic reasoners. And we do that through a no-code system that really provides people with explainability so that they can first assist those in making decisions more quickly by surfacing them and taking action, and then over time, evolve themselves to a fully autonomous state. So thank you for your time, and I appreciate it.
Thank you so much, Jose. And now we're going to move on to Boston Materials, and Anvish is going to provide this presentation. Thank you.
Hi, Anvesh Gurujala, CEO and co-founder of Boston Materials. Let me share my screen. Great. So today we're going to be talking about a specific topic in AI data center cooling, and specifically what we're doing with thermal interface materials. So let's kick things off. A key trend that we're seeing is that the AI chips that are actually the heart of the data center are generating tremendous amount of heat. So these devices are typically kilowatt scale processors. And on top of just the sheer power, they're also physically getting larger, right? It's common now in the market to see devices that are the size of your palm, and trailblazers in the field are also producing devices the size of your face, right? So you have this trend of AI chips that are powering the AI data center wave are getting larger and more powerful. And this is leading to specific new challenges in thermal engineering and also mechanical engineering as well. So on top of that, what we're also seeing is that the modern AI data center is actually using liquid cooling. So liquid cooling is actually using water or coolant that's flowing through the system to actually conduct the heat away from where it's being generated, which is the processor, the AI chip. This is actually a breakthrough innovation and deviation from where data centers historically have been, which is just using air to cool the chips. So when you're now using these more exotic high-performance cooling systems, we're finding that the industry is finding that there's still room for optimization. And now it's maybe not the cooling system, but actually the interface between the chip and the cooling system is where there's a tremendous bottleneck. And so thermal interface materials, as they are a thermal interface between the silicon chip and the cooling system, is now actually accounting for 40% of the total thermal resistance in the data center system. And this is a problem and an opportunity. And so at Boston Materials, we are a materials company. And so our innovation is a technology called Z-axis fiber. We are vertically aligning high thermal conductivity carbon fibers to create this sponge-like film that we're infiltrating with a liquid metal alloy. So this is our patented technology. What it does is it provides very low thermal resistance. So it actually conducts heat very efficiently between the chip and the cooling system. But on top of that, like I mentioned earlier, these devices are actually getting quite large, which means that they're not perfectly flat. They're actually warped, highly warped in many cases. And so you need a material that provides good heat transfer, but is also very compliant and, if I may use the word, squishy, right? And so that's exactly what our technology does. And we're actually producing these materials here at our factory just outside of the Boston area. And we're using advanced roll-to-roll manufacturing processes, clean room operations. We've actually scaled up quite substantially here in our facility. And we're also providing our customers with a North American source for these types of advanced thermal solutions. So, okay, that's great. Material competitive properties. What does that actually mean in data center operations? So what we're seeing in actual data center environments is between 4 to over 10 degrees Celsius drop in actually chip temperatures. What this actually means is energy and cost savings, right? It also could mean longer device life, which could help with amortization and depreciation of CapEx in data centers. And it could also mean overclocking too. Now that you have more of a thermal budget, an overhead, you can actually use that to run the same processors at higher speeds, thereby producing more output for the same given infrastructure. The other key thing that was brought up is not just about energy and costs savings, but it's also water consumption. If you're co-locating data centers near cities, right, high population density areas, water is also another competitive resource. And so what we're also showing that with our technology, the material property benefits can manifest as actually reducing water consumption. So we're seeing in liquid cooling systems, we can actually run at 25% the flow rates and still achieve the same cooling performance with our thermal interface material. So these are just some areas that Boston Materials is leading the pack, providing a thermal interface material that can produce between 4 to 10 degrees Celsius cooling effect and also reduce the water consumption too by a substantial factor. So if you're in AI data center operations or you're developing AI data center chips, this is a technology worth evaluating in your decision-making process. So with that, I'll end my presentation and just kind of, I know the previous company is Beyond Limits, so our taglines also go beyond limits, so it's a nice segue. So thank you for your time. That's everything I have for the team here today. Thanks.
Thank you so much, Anvesh. The next up is going to be the Climetric presentation, and Boris is going to be sharing with us. Thank you.
All right. Hi, everyone. It's a pleasure to be here with you today. My name is Boris Blatnik. I'm the founder and CEO of Climetric. We're using cutting-edge AI to make the world's buildings smarter, greener, and dramatically more efficient. Buildings today are hemorrhaging energy and money. HVAC systems, which can account for up to 40% of a building's energy use, are still largely dumb, reactive, and disconnected. A staggering 30% of HVAC energy is completely wasted due to inefficiencies. They don't adjust in real time to things like occupancy or weather, for example. Repairs are reactive, expensive, and disruptive. And managing everything centrally is a security risk waiting to happen. This isn't just an inefficiency, it's a missed opportunity. Climetric is an edge AI HVAC optimization platform designed for today's buildings with a focus on commercial buildings and data centers. What makes us different is we essentially reduce HVAC energy consumption by up to 30% autonomously. Our edge AI acts instantly at the source, no lag, no cloud dependency, and far more secure. We predict maintenance issues before they become costly failures. And of course, we create better indoor environments by factoring in things like occupancy, air quality, and weather conditions. It's like giving your building a real-time brain with no IT headaches. This isn't a niche. The global HVAC market is projected to hit 300 billion in the next few years, and building owners and managers are under extreme pressure to have them smarter and more sustainable. The need for HVAC optimization at scale is real and growing, as both Sid and Elizabeth mentioned during the panel discussion. Climetric is a subscription-based platform with pricing based on building size and complexity. It's easy to onboard, integrates into existing systems, and delivers immediate ROI through energy savings and system uptime. Green buildings that reduce HVAC-related emissions qualify for credits in voluntary carbon markets. We've built in the ability to automatically track, verify, and monetize those savings, making sustainability not just possible, but profitable. The magic under the hood? Well, we've secured an exclusive from SRI for their Edge AI stack. It enables on-site data processing, allowing our AI to respond in milliseconds, not minutes, without sending data into the cloud. That means faster decisions, airtight security, and full regulatory compliance. Others in the space are innovating, but they rely heavily on cloud AI. Climetric brings a new level of intelligence, autonomy, and security to the edge, right where it matters. What sets us apart? Our edge-first architecture, faster, safer, and offline capable. Autonomous optimization, not just alerts, but actions. A focus on real-time, secure decision-making for critical systems. We're not just a software layer, we're a performance engine for the building itself. Our leadership brings decades of experience in AI, sustainability, and building systems. We founded and scaled companies, worked with deep tech partners, and know how to move from lab to launch. We were one of 8 companies selected into the prestigious CBIT accelerator in Tokyo. We're in advanced discussions with Johnson Controls, NOAA, and signed an NDA with one of the major Japanese developers to start a pilot in Yokohama, Japan. Pilot programs expected to kick off this year in Japan and the Middle East. Climetric turns HVAC from a cost center to a competitive edge with better performance, lower emissions, and stronger security. Thank you. That's the end of my presentation. Let's see, how do we...
Boris, thank you so much for sharing that with us. We really appreciate it. And now we're going to turn to grid care, and Shanice is going to be presenting for us.
Hey everyone, I'm Shanice at GridCare and very excited to be here to share with you how we are helping bring speed to power for AI data centers. Feels very timely given everything that we discussed in the panel discussion earlier today. As you all know, demand for power is skyrocketing because of AI compute needs. It's not just AI training workloads, it's also inference workloads and advanced manufacturing coming back to the US that is putting an unprecedented strain on power demand for utilities. From a data center perspective, the need is urgent. They are trying to deploy gigawatt scale data centers in 12 to 24 months, but are getting responses like 5 to 7 years and several $100 million in grid upgrade costs from utilities. And so they're turning to solutions like reopening 3 Mile Island or other sources of off-grid power. We think that the fastest, cheapest way to energize a data center is by getting more power out of the existing grid. And what we realized is the grid today is less than 40% utilized. This is not a grid care number. This is a number given to us by utility execs across the country. So how can it be that we have this massive asset that's so underutilized, and on the other side of it have data centers and other sorts of load that are trying to connect using all sorts of different ways? And we think, again, the fastest, cheapest, best way to get more power is by getting more out of the existing grid. Because even just a 10% unlock will mean that we can extract over 100 gigawatts of power and will allow for over $1 trillion of infrastructure capital to get deployed on the back of it. We're able to do this because of the AI-powered platform and proprietary playbooks that we've built at GridCare that allows us to look at the grid in a very unique way across both geography and time. Instead of looking at the grid one node at a time, we look at it as a system. We figure out where the constraints exist. We figure out the probabilities of those constraints occurring and what mitigations we can put in place either on the utility side or on the data center side to be able to unlock a lot of the white space that exists most of the year over many years. We have 2 go-to-market plays with data center developers. The first is if you have an existing site that has a large physical footprint but is power constrained, we help you find and unlock more power at that existing site. So this could be a warehouse that you're trying to convert to a data center. I see a Prologis person on the chat. Or it could be that you want to add a new building to your existing cluster, but the utility is telling you that that substation's maxed out. We help you do that without incurring new grid upgrades or the long timelines that you're currently getting. The second is power development for a greenfield site. Sid alluded to this in the panel earlier, but siting a data center, we are flipping the narrative from land first to power first. And once we've identified where the pockets of power exist, our platform is able to screen for latency, fiber, community sentiment, existing clusters, everything that you need to be able to site your location effectively. We're really focused on win-win-win outcomes. We, of course, want to partner. I mean, we are working with hyperscalers and large data center developers across the US today on their various projects. But this is also a win for the utilities who are trying to drive beneficial load growth in their territories and drive investment and new jobs. We're able to do what we're doing because CritCare, although we're a startup, a seed stage startup, we are built on over a decade of groundbreaking research at Stanford. Amit Narayan, our founder and CEO, first built and scaled a chip design company that he exited, and then built and scaled a virtual power plant company that he exited to Schneider. And this is a culmination of bringing the AI and energy worlds together. And our co-founders, Liang, Ram, and Aaron, all have been in this industry for decades, both at hyperscalers and at Stanford, leading research in AI for power systems. We're also fortunate to be backed by leading investors, for example, Themasek's Deep Tech Fund, Zora, as well as Breakthrough Energy, and angels from the leading tech companies. We've also been able to get advisors who have previously run utilities as well as led data center development at places like Meta and Microsoft, and really think that we have the right combination of both experience on the technical side and business side to be able to solve this problem. So if you're interested in expanding power capacity for your existing data centers or siting new ones, please get in touch. Would love to hear from you. Thank you.
Thank you so much, Sunise. We are now going to move into a presentation by Ming, who is representing NovoLink. So Ming, please.
Yeah, it's an honor to be here, and thanks for inviting NovoLink. We are a Carnegie Mellon University spin-off with a decades research in fundamental heat transfer, and it is also sponsored by National Science Foundation and APAI Cooler Chips program in the early discoveries. Our mission is to set a new global standard in thermal interface management. The thermal interface is a foundational layer in AI chip performance and energy efficiency of advanced computing systems. Disruptive technologies often arrive quietly with the power to transform the entire industry once recognized and embraced. I think this moment is right here. So we're talking about the AI data center and the advanced GPUs producing enormous amount of heat. And then 30 to 40% of global data center energy is used in cooling to put off the fire. And then this chart visualizes in the last 2 decades how the power density of the GPU, CPU has exploded in the power density growth. And then the roadmap is pointing towards into 3x, 4x increase down the road. So the chips are getting hotter, and then the cooling systems are becoming more efficient when the AI data center is migrating into direct liquid cooling. So what does that mean? It means the new bottleneck needs to be addressed, which is the thermal interface that is between the liquid cooling cold plate and the GPU, CPUs. So NovoLink is staged to solve this challenge. Our breakthrough nanocomposite layer transfers heat 10 times more efficient than the industry standard. The work has been published by Nature Communications. We are enabled chips to running 5 to 10 degrees cooler instantly. So when we look at the thermal resistance of various materials in the industry, solder is a gold standard, and then there's commonly used thermal interface material like a thermal pad and grease. NovoLink is the next generation performance leader. We have demonstrated thermal resistance at 0.7 millimeter square Kelvin per watt. That's 2 or 3 times better than solder, and then 10 times better than some of the commonly used thermal grease and the thermal pad materials. We also help to mitigate the dynamic warpage issue that the AI chips are facing. So there are requests from customers to be able to accommodate from 50 micron up to 150 micron up to 250 micron, or there's even higher numbers in the roadmap. Our material is adaptive and it keeps full contact at all time at the interface. So in a nutshell, our metal nanostructure regulates the heat both vertically and laterally, and then provides perfect contact at both interfaces. That's leading into higher performance for chips. That means you can running at a higher performance power level, or you can running at a lower temperature to ensure your reliability in the field. We also solved the dynamic warpage issue, as mentioned. Overall, it will save cost for the data center. So for bringing in 10 times better, lower thermal resistance than leading materials, and then that's transferring into over 30% efficiency gain in the liquid cooling system, we are calculated to bring in enormous amount of energy and economic savings to the data center. For example, by 2030, NovoLink solution will be able to provide over 66 terawatt hour saving to the industry. When that's translated, that amount of energy can be used for powering different states for months, and it can be used for powering the different hyperscalers data center for years, which means this advanced thermal interface material has the power of several nuclear power plant, and then that can allow the data center to run their have the running the data center for free for years by adopting this advanced thermal interface materials. So computers and the data center team are just representing 25% of the global team consumption. So we are building a solution for every industry with a heat constraint challenge. We are currently actively working with all stakeholders in the ecosystem for product qualification, including semiconductor companies, hyperscalers, data center server OEMs, infrastructure ODMs, and cold plate companies. At NovoLink, we have a world-class leadership team. Our COO, Bob Werner, and myself, we have years of experience in the industry, launching products, achieving over $1 billion revenues. And then scaling, we also have experience in scale startups from within a year and a half. And in my last experience, I have a scaled company over 100 employees and achieved over 100 millions of fundraising. So please join us in making global AI advancement sustainable. If you are an ecosystem partner, we look forward to collaborate in the technology. If you are an investor, we will be raise our next fund very soon, and we look forward to getting in touch. So we're not just solving thermal bottlenecks, but we're here to make AI more efficient, more scalable, and ultimately more sustainable. So we are here for AI, we're here for energy, we're here to reshape the thermal foundation of the future. Thank you.
Thank you so much for your presentation. Next, we're going to have the Ogre presentation. I'm just curious about that company name in general. And Razvan will be presenting. Thank you.
Everyone, glad to be here. My name is Răzvan Popescu. I'm leading partnerships and customer success at Augur. Augur, it's a startup company based in Bucharest that has built an energy forecasting and optimization platform. Our vision is to build a platform that brings together existing solutions into the market with our own solutions in order to improve energy efficiency, reliability, and sustainability across the entire energy value chain. We were founded in 2021, and we still have a small team, and we want to keep it as small as possible of 25 people working from various locations across Europe. Now, Sid and my fellow presenters already mentioned, I believe, all these challenges that the industry is facing nowadays. For the ones that are not familiar with the energy sector, I would like to mention one key principle for the electricity grids. The electricity consumption and the electricity production needs to be equal in balance at every single moment. So all these challenges that you are seeing on the screen are amplifying the efforts required to keep the grid in balance. So understanding how difficult it is to keep the grid in balance, we realize how important it is to know in advance what the production or consumption would be for the grid. So this is why we have built a platform that includes 6 independent solution that covers renewable production forecast, solar and wind, demand forecast. So we can deliver forecasts for millions of consumers, households, or commercial clients, EV charging stations forecasts, prosumer forecasts that are usually either households or commercial clients, both producing in general through solar panels, but also consuming energy. And the last 2 solutions, technical losses and anomaly detection and non-technical losses. All these solutions are powered by our AI forecasting engine, so that we are not delivering the same model to all our clients. We have built libraries with specialized models, and depending on the client profile, the data we are retrieving from multiple sources, the engine is deciding which of the models is expected to deliver the most accurate results, and those are sent or displayed for the client. Now, we are working with clients across the entire value chain, including data centers, and depending on their needs, we can deliver a single forecasting solution, or they could bundle multiple solutions. And all these informations are available within a single platform, so they don't need to switch from one platform to another. We are working with clients across 13 countries. Just to give you some examples, with Enel, we are working with their distribution companies in Romania, delivering technical losses. With DEI, it's one of the largest energy operators in Greece, and we are delivering demand forecast for about 3.2 million consumers in their portfolio. We are working with PSE. PSE is the independent energy system operator in Poland, and we are delivering wind forecast for all the wind assets connected to the Polish grid, and so on. Now, in terms of our roadmap, we started back in 2021. We already closed 2 financing rounds that were used to build the 6 solutions that I just mentioned, and we still have funds to improve the accuracy of the models, to build a new layer of intelligence on top of forecasting engine, so that the engine will be able to build new models by itself. So we are aiming to have a fully autonomous AI engine factory. And recently we just signed a contract for an EU grant that will be used to build energy optimization functionalities and also to improve our API integration capabilities, because as I mentioned, our aim is to integrate with as many solutions already available into the market. When it comes to Series A investment round, we are aiming to close that round end of Q1 2026, beginning of Q2 2026. We are in Bucharest and in London, and if you want to learn more, we could definitely answer to any of your questions. Thank you.
Thank you so much for your presentation. Our last presenter today will be Tibo Energy, and Remco will be providing that for us. Thank you.
Yes. Hello, good evening all. At least it's evening for me. Let me share my screen. Yes. So Tibo Energy is a SaaS company. We're developing energy management to optimize energy flows and to upgrade the efficiency of the grid. We use AI to do this, and I'm just giving you a vision of how we use AI and how we think the market will change in terms of energy and what AI can help us in doing that. So when we talk about energy transition, we are talking about powering the tomorrow's grid. We see many companies, and I think the Netherlands is one of the most congested grids all over the world. We adopted EV very intensively, and also we adopted solar in our country very intensively. And this comes with many challenges. And we see these challenges spreading all over Europe and many other countries in the whole of the world. So when we're talking about moving from fossil fuels to electric renewable energy, we see that this requires a grid in almost any country that requires an infrastructure that we do not have today. And possibly we do not have this infrastructure in the next 5 or 10 years. So what we need to do is just being smart with what we have and create more efficiency with the grid that we today have. So when we are talking about the energy transition here, we also talk about decentralizing the energy consumption, storage, and supply. What you see here in the picture is, of course, households that also have more and more often have like home batteries. They have sun. They have PV systems on their roof, and they are a user of energy, driving electric cars, and using more and more electricity for cooking, the bubble bath, the sauna, and name anything that all the luxury lives gives us today. But in a larger scale, you can look at this as a whole living area that needs energy and can store energy. And on an even larger scale, maybe next to this living area is also an industrial area with commercial sites. As you can see, windmills and all these things connected to the medium voltage grids. So decentralized energy grids, and one of the previous presenters already said it. The grid always needs to be in balance. So every energy used, it needs to be generated somewhere, and every energy that's being generated, it needs to be used somewhere. You cannot just throw it away or make something up. So there's a lot of key challenges in getting this to optimize this grid in a way that nobody wants to the grid to fill, and to be able to do this, it's a big puzzle. So what we do with Thibaut at Thibaut Energy is we create software to crack that puzzle. And by doing this, we do forecasting. So we forecast supply, we forecast demand, and we forecast how to use the storage that we can use in the most efficient way. And unfortunately, we're talking a lot about carbon emissions, but many companies that we are focused on, we don't do households, residentials. We're focusing our software on the high energy users like distribution centers and industry that uses a lot of electricity. They're very much focused on the pricing, which we don't care because green energy is also the cheapest energy and the other way around. This now today is a mathematical puzzle to optimize this grid. And we use AI for this. Of course, AI is a whole load of different ways of AI. So our AI is more focused on machine learning. If we have the same puzzle and we ask 20 times to crack the puzzle in the best way, we need 20 times the exact same answer, which is different from the language models that you might use every day, like ChatGPT. Okay. So what's next? Because today we are optimizing behind the meter locations like distribution centers, using a lot of energy with e-trucks, producing a lot of energy with large roofs and solar, have the possibility to store energy in either battery storage or maybe a freezer or anything else. But we also move now to energy hubs where whole communities work together. And the next step is, of course, where we see that energy hubs are connected to each other. And it's our strong belief that the way we use the grid today will not be the way we will use the grids in 5 to 10 years, because we really strongly believe that the grid will exist of many small energy management systems running small locations, communicating with close with energy management systems that are connected with each other to on the grid, close to that. And then the whole grid will start acting like a nervous system. So every energy ecosystem managed by an energy management energy management solution will be able to communicate with the surrounding energy management systems that are responsible for optimizing the grid of that area. So for the first puzzle, machine learning works very well, but for this next puzzle, AI is really needed to do this. So we strongly believe that that it will go this way, and at Thibaut Energy we are working on solutions where we can create with our software a broader way to manage the grid. So if we can do this, a lot of the challenges that we have today in our current network, like imbalance, is that still a problem? So some of the questions that, some of the challenges that we have today, will there still be those challenges in 5 to 10 years if we have this new managed way of managing decentralized networks? Questions like, can AI prevent energy imbalance? Do we still need imbalance traders? Or can energy prices approach to zero I think we will more probably pay for very low energy, but we'll still pay for the transport. Can grids be auto-healing? I think those are really the challenges and the questions that we should start to answer today. And yeah, that's what we are doing. So yeah. My name is Remco Eickhout. I'm the CEO of Tibo Energy. If you have any questions about how we do this and if our solution is fit to manage your grid, just contact me, and I'm happy to give you a presentation of our solution. Thank you very much.
Thank you so much for your presentation. And actually, we're being very efficient, as in we've been trying to do with energy and AI today. So thank you for joining us, everyone. We will be sending out a follow-up to this webinar next week. So please check your email for that. It'll provide information on how you can revisit this discussion and also provide some information on how to contact the startups that presented today. I just wanted to highlight one of our upcoming events that I think is very relevant to this audience, and that would be the GCV Connect Houston event, which will be on September the 17th. This is our third edition of doing something there, and it will be part of the Houston Energy and Climate Startup Week. So we'll be gathering together CVCs for a half-day program on the 17th. So please mark your calendars. All of these events are actually listed on our website, which is globalventuring.com. So please feel free to visit the website and to sign up for things that are of interest to you. And then finally, I just wanted to share that if you need to, excuse me, I forgot about the Institute. Thank you. We do have professional development programs that we offer through the GCV Institute. Here's a list of our upcoming courses. Some of them are live online and some are in person. We do these literally all over the world to try to help with different time zones and different needs that might be in a particular region or a country. So that information is also available on gcvinstitute.com. So please feel free to check out more about the courses that we offer and the time zones. And then finally, if you need to get in touch with somebody at GCV, these are the head folks that lead up editorial, membership, professional development, and our commercial department. So thank you so much for joining us today. We look forward to seeing you or offering another webinar that would be of interest to you. We do a monthly webinar series called The Next Wave that's on more topical issues and themes. So that's offered the second Wednesday of every month. So tune in for that as well. Thank you and have a good rest of your day.